and will provide configuration and troubleshooting tips for the Nexus 5000 series. Welcome, Lucian.
Thank you, Dan.
Now I'd like to briefly outline the format for today's Ask the Expert event.
Lucian will start with a short presentation on the Nexus 5000 for the first 25 minutes of the program, and then we will dive into the live question submissions for the remainder of the event. During our live presentation, you may submit a question to be answered by Lucian and a team of Cisco technical experts using the submit box on the left side of your console. Simply type your question and press submit. To see the latest questions and answers during today's presentation, be sure to click the refresh button located just under the slides. You can scroll up to see previous answers in the Q&A box. The team of technical experts is well-versed in Nexus configuration, so please begin posting your questions now to give us the best chance of answering them. We'll be asking polling questions during this webcast, and we encourage you to participate by answering them. In fact, the first person to answer each of the 3 polling questions will win a 1-year Premier Pass to Cisco Live and Networkers Virtual, which will give you full access to hundreds of PDFs and on-demand webcasts. So that's 3 polling questions with three chances to win. Now, let's get started with today's event. We'll kick things off with a polling question. What topic are you most interested in today? VPC or virtual port channels, the Nexus 5000, or the Nexus 2000? Take a moment to answer. Okay, let's have a look at these results. Looks good, Nexus 5000 with VPC right behind it. Okay, now I'd like to hand the mic over to Lucian, who will provide insight on Nexus switches.
Thank you, Dan. Welcome, everyone. In today's agenda, as we will be covering the following: virtual port channel, Nexus 5000, and the Nexus 2000 series. I'd like just to quickly mention the wording I'll be using. You'll see me using Nexus 5000 or 5000 or 5K. And for the 2000, when I'll be talking about 2000, you'll hear it about as Nexus 2000, 2K, or Fabric Extender, and as well FEX. So those are the words I'll be using for the 2000. I'll mainly use the FEX word. Now, as we saw in the polling, we'll start with the virtual port channel. And let's first talk here about the terminology we'll be using. So here is a diagram showing VPC, and we have the Nexus, we have the 5000, 2 switches, a pair of 5000, and we have a FEX downstream. So a VPC peer will be what we call a switch forming one of the pair. A VPC peer would be the other 5K in this one scenario. VPC member port, one of a set of ports that will form a VPC. VPC, the virtual port channel, is the combined port channel between the VPC peers and the downstream device. A VPC peer link is the link that is used between the VPC peers to synchronize the state and to carry multicast, broadcast, floating traffic, and data traffic in case of VPC member port failure. There's also the VPC peer keep alive link. The peer keep alive link is used between the VPC peer switches. It carries a heartbeat, and it makes sure that the other switch is alive. Finally, CFS stands for Cisco Fabric Services Protocol, and this is used for state synchronization and configuration validation between the VPC peer devices. Now let's move ahead and see our feature overview here. What does VPC do and allow us? It allows a single device to use a port channel across 2 upstream switches. So this is the difference really between a port channel and a virtual port channel. It also eliminates spanning tree protocol blocked ports. It uses all available uplink bandwidth. In other words, as a regular port channel would have an active-active scenario where both links will be up, or more than two, depending how many links you have in your port channel. Dual home servers will operate in active-active as well as switches. And VPC provides fast convergence upon link device failure. Now, let's talk about designs. What are all the options that we have for VPC with our 5000 and 2000 series? On the left here, you can see three designs which are without VPC. So the top switches would be the 5Ks, and downstream would be the FEX, and the little icons would represent a server. So without VPC, what we could do is have one link between a 5K and a FEX, or a port channel. We could have a pair of FEXs connected to a server. That's the second drawing. And the server will be in active-passive mode here. Either one link will be active, and if that link fails, the other one will come up. This is without VPC. With VPC, we provide high availability in case of failure of one of the switches or the fabric extender. So VPC designs, as you can see here, first off, the first drawing in the middle up represents a VPC to the FEX. So here we have two VPCs from each FEX going to the 5Ks. So instead of having two links from each FEX going to a single 5K, we cross them. And so each FEX has two links, but to both 5Ks, and both are active. So in case of failure of one of the 5K, traffic will still flow to the other one. We can also have VPC to the server, and those are the two drawings down in the middle. And there, the server will be active, so that both links on the server will be up, and each one will go to a FEX, to a different physical FEX. So this will be called VPC to the server. Starting 4.2 code on NXOS, and with the 2200 series fabric extenders, we can have dual VPC. And here you see we have, this is the last drawing on the right, the bottom. We have VPC from the FEX to the 5K, and we have VPC to the server. So we have dual layer VPC. Let's move ahead now and talk about the path forwarding. In this example, we'll take unicast forwarding, so you can understand what's the traffic flow on a VPC pair. So let's say we have a host A down on the right, and host A wants to talk to host C, which is on the top right. So bottom left to top right. Host A will first send a packet to host C, and it has a port channel. It has one connection to each FEX. So host A will run its own hash algorithm to select one of the paths. So the operating system will choose with the NIC cards where to send the traffic. So let's say it sends it to the left, to the FEX on the left. The packet is received on the FEX, and then the FEX will run a hash algorithm to select the fabric uplink. Well, here in this example, it has a port channel to the 5K, so it will be either one of the two links. And so the FEX forwards this packet to the 5K1. The 5K1 on the left will now learn host A, and it will flood the packet to the VLAN members where host A is as well. One copy will be sent to the switch, which is upstream, and one copy will be sent to host B, and one copy for the peer link. So it will flood the packet. Now the 5K2, which is on the right, will flood the packet to the VLANs, to all the VLAN members except the VPC peer member port to prevent duplicated packets. So in here, it will not send the traffic up to the switch upstream or down to the FEX. 5K1 will update host A entry to 5K2. So 5K2 will have it in its MAC address table. And the packet reaches host C. Once it reaches the switch upstream, it's forwarded to host C, and host C receives the packet. Now, let's talk about the return packet. So host C would like to talk back to reply to host A. So sends the packet, and it's received by the switch upstream. The switch upstream, as you can see, also has a VPC to both 5Ks, and for that switch, it's as one logical switch. So the switch on the top will run its own algorithm and select the path. And let's say in this case, it will select the path to 5K2. So switch sends the packet to 5K2, and 5K2 will now search in its MAC address table an entry for host A. And we'll find that this entry for host A points to its local FEX that belongs to the VPC bundle. So 5K2 will send the packet to that FEX on the right. And once the FEX receives it, it will just forward it to host A based on the internal header constructed by 5K2. And now host A has received the packet back. Now let's move on and talk about VPC interaction with spanning tree. Spanning tree protocol is deployed to prevent VPC failure cases. Only the VPC primary switch will be running spanning tree protocol. The secondary VPC member, here 5K2, will forward BPDU frames to the primary. Also keep in mind, the VPC peer link is not blocked via spanning tree. And how does the VPC primary election work? Well, it's based on priority. So an election happens, and in this one example, the 5K1 on the left is the primary, and the 5K2 on the right is the secondary. Now, as we spoke about how VPC works, let's go ahead and see two examples. The first example is how we're going to configure VPC to the server. So, in other words, an active-active NIC teaming on the server. So here is the configuration for it. First, we need to enable VPC. So we'll go ahead and do feature VPC. We'll also enable LACP, so feature LACP. We'll configure a VPC domain number. So, for example, we'll pick a number, and this number has to match on both switches. So in this one slide here, you will see the details of configuration for 5K1. They will have to be duplicated on the other switch as well. Now, we pick, for example, VPC domain 1 on both, and then we will configure what we call the peer keep alives. So the peer keep alives should be running over the management 0 interface and the management VRF on the 5K. So the way you configure this is with the peer keep alive destination, and you provide the IP address of 5K2 in this example, as we're on 5K1 for the config. Now, once we've configured our VPC domain and our peer keep alives, we're going to go ahead and configure the peer link between both 5Ks in orange. This is the second step. So, for example, here we have two interfaces, Ethernet 1/17 and Ethernet 1/18. We'll place them in a port channel, mode active, so we'll use LACP. And under that port channel, one thing we will do to mention that it's a peer link, we will type VPC peer link. This is how our 5Ks will know that this is the peer link to the VPC peer. Also, we'll use a trunk, and on the trunk we'll allow all the VLANs that are that will be used on the VPC downstream. So all your VPC traffic, all the VLANs that are used, needs to be allowed on the peer link. Once our peer link came up, now we can go ahead and configure our FEX. So on the FEX side, in our example here, let's say we have Ethernet 1/7 and Ethernet 1/8 on the 5K1 that goes downstream to the FEX on the left. We'll go ahead and place those two ports in a port channel 100 in this example. And for this port channel, we'll say that it's a FEX, so we'll say switch port mode FEX fabric, and FEX associate 100, so we'll associate FEX 100 to it.
This will be just a regular port channel between the 5K and the FEX. And now, here comes our server configuration in green. There, we will configure, and the configuration happens on the 5K. There's no configuration that can be made on the FEX. All the FEX config happens on the 5K. So now to configure the VPC to the server, we'll go in the port where the server is physically connected on the FEX. So as we decided our FEX number will be 100, then the port and our server, let's say, is connected to port 1. We go to interface Ethernet 100/1/1. We call a port channel, so in this example, port channel 10. And we will say that port channel 10 is part of VPC 10. The numbers are arbitrary. You can decide what you use, but I strongly encourage you to use consistency between your port channel numbers and your VPC numbers. You will do the same configuration steps on 5K2, and so the other FEX will also know that for this port channel 10, it's part of VPC 10. And that way, those two links will come up. And here you have configured VPC to the server with an active-active nicktaming. Now let's move forward and now talk about VPC to the FEX, where one FEX will have links to each 5K. So in case of failure of one of the 5Ks, the FEX and the servers connected to it will have connectivity. The first two steps are the same. Configure your VPC domain and your peer keep alive, and configure your peer link. The only difference here with the previous example is that we'll configure VPC on the port channel that goes to the FEX. So we configure the port channel for the FEX about exactly the same, but we'll only add a VPC statement in there on both 5Ks so they know that we have a VPC formed. So in this one case, we have two cables going up to the left, 5K1, and two connection uplinks going to the 5K2 on the right. And we'll on both 5Ks, we'll call it, for example, VPC 100. And this will conclude how to configure VPC to the FEX. Now, let's go ahead and talk a little bit about how to troubleshoot VPC, how to find out if VPC is properly set up, and how to find the problems and to tackle them. The first command here I would advise you to use is the show VPC brief. The show VPC brief will resume the brief of your configuration. It will tell you your VPC domain ID. It will tell you the status of your peer, if your peer adjacency has formed OK. It will also tell you the status on the keep alives. So it will say peer is alive if it can reach the peer across its management 0 interface. Configuration consistency status, if config consistency has happened, it will say success. VPC role, here you will be able to read if it's your 5K where you issue this command is primary or secondary. It will tell you how many VPC are configured, and it will tell you what is your peer link, if it's up, what is the port channel used for it, and what's the VPC number mapping. What are the VLANs allowed, and then down it will list all the other VPCs with their port channel information and the VPC ID number. The second command to use for VPC peer is the show VPC peer keep alive. If you like to troubleshoot a peer keep alive issue where your peer doesn't come up and says not alive or never was alive, then run this command, show VPC peer keep alive. Here there's two outputs. One is for each 5K, and so here you can see for each one of them the status. So in this one example, it will say peer is alive. It will say how long it was alive for, what's the actual status, when was the last peer keep alive received, on which interface, what is the IP address, and so forth. If you like to look about who is primary and secondary, have more details about that, the command to use is the show VPC role. And this will tell you who's the primary, what's the MAC address, what's the system priority, and on each one. So you can compare, and what are their MAC addresses. This is for the VPC peer, how to check your configuration. Now, let's go ahead and talk about consistency. How to make sure that you are consistent in your configuration over both 5Ks. So one command I recommend you to use is the show VPC consistency parameters global. And you can run this on each of the 5Ks. And there's two main columns there. So in this one output from one 5K, you can see the local value column, and on the right side, the peer value column. So basically, this will compare the values that are locally configured to its peer. And here, what you want to look for is differences. You shouldn't have differences for everything which is type 1 in the column where it says type, the middle column. Everything that is type 1 needs to match on both 5Ks. If you see a difference there, well, if it's the peer value that is different, go ahead on your other 5K and make the configuration change. And if it's on the local, then go ahead and make the change on your local. But you need to have, if you're seeing consistency error messages, well, this show command will help you find out what's different. You can do the same thing for the port channel to defects for the consistency. So for this, you can use the command show VPC consistency parameters interface port channel, and then you can specify the port channel you'd like to look at. And here we'll tell you, again, type 1 are the values that need to match on the local 5K and the pure 5K, and those that are not 1 are okay to be a little different. If you're wondering how we know the local and the peer, this is when CFS comes in, and this protocol helps each 5K to know the peer values. And now I'll hand the mic to Dan. This concludes our VPC section.
Okay, everyone, let's have a look real quick at our second polling question. How familiar are you with the NX OS Nexus 5000, Nexus 2000 series? Never heard about it, someone heard about it, familiar, or using it every day? Take a moment to answer. In the meantime, I will remind you that you can download today's PDF, the full presentation, in the upper right-hand corner of your console. Okay, let's have a look at the results. Okay, very good. I'm going to hand the mic back to Lucian. Please continue.
Thank you, Dan. Now let's go ahead and talk about Nexus 5000. All right. First off, let's go ahead and talk about configuration. That's going to be our next 4 slides, and after that, we'll go ahead and talk about troubleshooting tools and other things to use, so you can analyze your network with the 5K. So the first main thing is connectivity. How to establish connectivity to your 5K so you can configure it. I recommend you to use the management VRF for that purpose with the management 0 interface. First off, you can use SSH or Telnet to connect to it. SSH is enabled by default, and if you like to use Telnet, then you need to enable Telnet on the 5K. So you need to go ahead and type feature Telnet and enable that. Once you've decided if you use Telnet or SSH, go ahead and configure management 0. So go on the interface management 0, provide an IP address. If you'd like to provide a default route, which is probably what you'll do when you'll be accessing the device from a different subnet than the management 0 IP, then go ahead in VRF context management and issue your default route statement. That's the method I recommend you to use for connectivity. If your design or business needs are that you have to use a 10 gig port and an interface VLAN, you can do so. For that, we need to enable first the interface VLAN, so feature interface VLAN, and add the VLAN to the VLAN database, the one that you'll use to connect. So VLAN and the number and exit. So you put in the database, and go interface VLAN and provide an IP address. Don't forget to unshut the interface. By default, interface VLANs are shut down. And here you can provide a default route following that to your gateway. But here we'll use the VRF context default instead of the VRF context management. Once we've configured connectivity, another fundamental thing is how to upgrade your code. The command is a little different than iOS here, and it's a little different also in the structure because there's two files. There's what we call the kickstart image, and then there's what we call the system image. So when you want to do an upgrade of your 5K code, you'll have to download two files, the kickstart and the system file from our Cisco.com website. And by the way, for the FEX code, you don't have to download anything different. The FEX receives its code from the 5K. So when your 5K runs one specific version of code, your FEX will run that version as well, and it will receive it from the 5K. So you have two images. Once you've downloaded them, the preferred method to use is with the install all command. And so the syntax is install all, kickstart, provide the path to it. So probably it's going to be your boot flash and your file name, and then space system and the file for the system file. When you use install all, this will update the FEX primary image in addition to installing the switch images. The FEX will remain online while the installation is in progress. And after the installation, the FEX will be rebooted along with the 5K. How long this process will take you once you've typed the command install all to when you come back? Typically, I would say it runs for about 7 minutes, about 5 minutes for the 5K and 2 minutes for the FEX. So I would say under 10 minutes is what you need for the downtime to get the image upgraded. There's a configuration check that's performed during image install. So you can see that with the show install all impact kickstart and show install all status. So you can see what has happened, if there's anything that went wrong and why. Keep in mind to use install all. This will also take care of upgrading everything properly, such as the power sequencer. So use that command and don't only set the boot strings to a newer code as you can do it like on iOS, but strongly recommend you to use the install all command. Another interesting topic about configuration is the jumbo frames. So the 5K is a 10 gig switch, and to process larger traffic, enabling jumbo frames helps. Jumbo frames are it's a 6 times bigger MTU, so it's optimized for 10 gig traffic. The maximum value for jumbo is 9216. You can, of course, use anything above 1500, and it will be called jumbo. So any value between 1500 and 9216 is a jumbo frame. So you need to enable jumbo on the servers in your OS, so for example on ESX, if you're running VMware, and enable it also on the 5K. By default, it's not enabled. So here is the configuration you can use to enable jumbo on your 5K. You'll create a policy map. You'll use the policy map network QoS that's already there, and you'll set the MTU. Also, there's another command, the command system jumbo MTU, that defines the maximum MTU size for the switch. However, jumbo MTU is only supported for system classes that have the MTU configured. So the command is system jumbo MTU and the value. It will be disruptive, so when you configure jumbo frames, you'll have a link flap there. Let's move on to password recovery. How to recover and get back on your 5K. So log into your console port, power cycle your switch. During booting, press Control bracket to get to the 5K boot prompt. In case you're running earlier code, 4.0 code and 1 or earlier, the process is slightly different. It's the Control Shift B to get to the boot prompt. And once you're in the boot prompt, basically the switch only loaded the kickstart image. And there you can go ahead and go in config T and change the password with the command admin password. And once you've done that, you load the system image with the load command. And once you get back on the switch, you'll be able to log in with the new password. So this concludes here our how to configure the main functions of our 5K. And let's now go ahead and talk about things you can use to troubleshoot your network. The first one I'd like to talk to you about is the ETH analyzer. This is a packet capture utility built in NXOS for packets, for the packets that are received to the CPU on the 5K, which are for destination to the 5K. So a couple of things to ask yourself: what interface you'd like to monitor. Is it your inbound, in other words, your 10 gig interfaces, or is it management, the management 0 interface? Do you want to save the output as a file, or do you just want to display it? Would you like to filter for a specific port and protocol? Do you want to just read a file that you already stored? And if you just want to have a sample, you could just preview the first packets. So now let's go ahead and see how to configure this. There's a little change in the commands in our code, but here are the latest commands to use. First off, what interface type you want to monitor? Here's how you do it. The only difference in the commands are, before we used to have ETH analyzer local interface. Now in newer code, the command is ETH analyzer local sniff-interface. So there's a little change there in the keyword, but everything else is about the same. So you have what interface you want to monitor. You can save the packet capture as a file. So if you like, save it as a PCAP, and then if you copy it to your computer, you can open it with Wireshark or TCP dump. You can filter for specific ports and protocol. You can use the regular filters, as in this example. You can read files with the following command, and you can preview capture. Note that the previews have changed in 4.2 code. It has moved from the default value of 100 to 10. However, if you want to change this back, you can. There's a command you can use to change it. And ETH analyzer does packet captures for all the traffic that goes with destination to 5K. Everything else is fabric switched and won't be captured by ETH analyzer. Which takes us to the next session: how to monitor traffic between hosts and switch traffic on the 5K. For this purpose, you can use SPAN. SPAN stands for Switch Port Analyzer. How do you configure SPAN? Well, it's pretty similar to iOS. One slightly difference is if you like to span fiber channel traffic. There's one slight change there where you will go in your fiber channel interface and you will set the switch port mode to SD. That's one difference. For Ethernet traffic, it's about the same configuration. You can configure your source port, and you can look at your span session, very similar as iOS with the show monitor command. Don't forget to go and unshut your monitoring session as well, or shut it down if you like to activate or deactivate it. Now, let's go ahead and talk about a few troubleshooting tools and a couple of issues that come frequently to the TAC. First, SFP issues, ports not coming up. Well, a very frequent message you can see in your logs is, you may see in your logs is SFP validation failed. For that, the command is to look at it as the show logging, so that will show you the logs, and you'll see an orange message for the validation, or it will give you a reason. In this example, for example, it could be an unsupported transceiver. So I urge you to go and use our compatibility guide and matrix for supported SFPs to make sure what you have is supported by the 5K. Another issue that comes is temperature issues. How to look at those? Well, show environment and show environment FEX for the fabric extender. This will tell you if there's temperature issues, and it will tell you as well if there's fans that may have failed. Crash. How will you now detect crash and the reasons for that? So a crash is usually recorded with a core file on the switch. If you issue a show version, it will tell you what was the last reset of the switch and the reason. You also have the command show system reset reason. This will list when and why your 5K has resetted or crashed. And once you know that, how to move on next? Well, usually a crash is followed by a dump of a core file. So to look at your core file and find it, type show core. This will show you if there's a core file that has issued. If you see a core file there, you can get the core file, and to do that, it's the last command I entered here. You can copy it, and you can use the different information, so the module number, the instance, the process name, and the PID. And you can export this, and this will be very helpful when you'll troubleshoot with the tag, the reason of your crash. So that's how you can get the core file. Now, this will end our session for the 5K, and I'll give the mic back to Dan.
Okay, thank you, Lucien. Let's go real quick to our last polling question. How many Nexus 5000 or 2000 series switches are deployed in your environment? 1 to 5, 6 to 20, 21 to 50, 51 or more. Take a moment to answer. All right, have a look at the results. Excellent. Okay, I'll hand the mic back to Lucien, who will wrap up the presentation.
Thank you, Dan. Now, we'll be talking about Nexus 2000 configuration troubleshooting in this very last part. So first off, there's 3 designs. Keep in mind. There's to keep in mind and to select. So pinning a single link or multiple links, using port channel and pinning multiple uplinks to it, or using VPC. When you can, I strongly encourage you to use VPC. If not, just use a port channel between your FEX and the 5K. How do you configure the FEX? You go in the interface Ethernet on your 5K that's connected to the FEX, and you tell the 5K that this is a FEX that's connected. So switch port mode, FEX fabric. And you have to choose a number for your FEX. So for example, a number from 100. So for example, FEX associate 101 here. If you connect your FEX to 2 different 5Ks, please use the same FEX number, especially if you want to use VPC. And this is how you verify it. Show interface, Ethernet, and the FEX. A few commands to help you verifying your configuration. Show FEX. This will tell you the FEX number, the description, the serial number, and what's the state of it. The show FEX detail will tell you more about your FEX, and you will see the fabric ports that are connected to the FEX and the pinned fabric ports, if they're pinned in a port channel or if it's static pinning. So if you're using port channel, obviously the primary fabric will say port channel. How to find out if you're getting mismatched messages on FEXs, look at what physical fabric ports are connected to the FEX and the serial numbers. So show interface FEX fabric will tell you that. And quickly, I'd like to tell you about 3 scenarios for troubleshooting. The first is FEX is not discovered. FEX is not discovered. So first off, check your power, your fans, your chassis lights, check your layer 1 cables, and check on your transceiver. Also use the version. Also use the compatibility version between FEX hardware and NXOS. If you're running 2200 FEXs, make sure you're at least on 4.2 code on the 5K. and connect a single, use a single connection to a 5K as well. Eliminate the other uplinks. If that doesn't help, of course, move on and contact the tag. Another issue is the FEX is not coming online. There's two reasons for this to happen, provided you have the proper power and fans and so forth. It could be a flash failure or an ASIC failure. If it's a flash failure, the FEX will not come online, and the show interface FEX fabric will not show the fabric port as active. Also, the locator LED will flash when the FEX fails to boot. If you have an ASIC failure, in other words, a hardware failure, the FEX may not come online if it's the hardware that is connected to the 5K. If it's other hardware equipment, you may see it in a show diagnostics. And finally, an issue that comes very often, identity mismatch. If you get a message saying that you have an identity mismatch, there's most likely a misconfiguration between your both 5Ks, or your cabling may not have been done right to your 5K. So look at the previous command to find out to which 5K you're connected and use the same configuration. Now, I'd like to talk about performance issues to conclude here. If you're observing slow traffic loss, or your application is not performing as expected, first off, think about, are you using a proper design? Because you'll have 10 gig uplinks and you may have 1 gig to your servers. Is your design right? Aren't you sending more than 1 gig traffic to a server that has only a 1 gig card? That would be the first question to ask yourself, and review the design guides, which I will indicate in the next documentation portion. Provided this, there are on the Nexus 5K, there are 3 things you can look at for this issue. So first is how to identify drops. There are logical and physical causes for the 5K to drop a frame, and there's also a situation when a frame can be dropped because of the cut-through nature of the switch architecture. If a drop is necessary, but the frame is being switched in a cut-through path, then the only option is to stump the Ethernet frame check sequence, the FCS. And stumping a frame involves setting the FCS to a known value that doesn't pass the CRC check. So when a frame is received on a 10 gig interface, it's considered to be cut-through path. How you would look there for drops? Well, the command to use will be the show platform FWM info PIF Ethernet and your port. And there, look at the last 2 lines for transmitted and received statistics, and look at the drops and the discards. A set of 2 other commands for the expected logical drops. You can look at the hardware. So those are the 2 commands here I provided you with, and look at the numbers of drop packets, and look at the increment over time. Do the increment. So issue the commands a couple of times, and it's the same for identifying drops. To see if you're an issue where drops are happening, issue the commands a few times. Another issue with performance is when your buffer queue is getting fooled. So show queuing interface and your interface. This will tell you if there are drops queued, if a queue is full. So when a queue is full, you need to increment discards in the respective queue on the egress interface. And you will observe discards. On the FEX, how would you look for drops? Especially here, I give you the commands for the 2148. They are a little different for the 2200s, but it's a similar structure. So those will also tell you about your queues and buffers and drops that you could experience. So those are key commands to troubleshoot performance and see if something is happening on your 5K and FEXs. In conclusion, I'd like here to give you a couple of pointers to documentation. For 5K, the product page, the config guides, the release notes, the installation hardware guides, and as well for the FAQs, a couple of key documentation places for your reference, and a few other things we covered today: password recovery, ETH analyzer, span, and finally, about VPC, the configuration guide, the quick start guide. I encourage you to look at the quick start guide if you're new to VPC. It's very well summarized. The white paper, and at the very end, the design paper. So this is a very good document that will cover the designs we talked about today, and all how things come together and what design to use to meet your business needs. And this will conclude my presentation. So I'll give the mic back to Dan.
Okay, thanks, Lucian. Great presentation. Also, thank you to everyone for participating in the event polling. Now it's time to answer some of the questions that our viewers have submitted today. By the way, if you can't stay with us for the discussion, be sure to click on the evaluation button to let us know how the session met your business needs and expectations. Also, the first 10 listeners to complete the evaluation will receive a $20 Amazon gift card. Okay, let's move into the Q&A portion of the event, and just please be aware you can still submit questions at any time. Let's move to our first question. Does the Nexus 5K support VPC sync between the VPC peers?
Excellent question. So we know that there's a CFS protocol that's used between the 5K pair, and as of today's code, there is no configuration sync. However, very soon in our next release of code, there's a feature called config sync, where we have worked to basically empower this, so you don't have to replicate all the configurations across each other and configuration changes. So look for our next code release, our next main code release, which is coming up, and the feature is called config sync.
Great. Let's move on to our next question. What is the most appropriate method of toggling the VPC role when there is a role mismatch?
Okay, when there is a mismatch for the VPC role, well, you'll have a VPC primary 5K, and the other one will be secondary. So typically, you will not see a mismatch. There will be an election based on the priority that will occur, and you will have a primary that will be elected and a secondary. In case of failure VPC scenarios, if we lose connection to the primary, let's say, the secondary can take over and assume the primary role, and it will tell you VPC secondary acting as primary.
Excellent. Let's move to our next question. I have a 5010 and a 5020. Can I use the ports with a speed of 1 gig?
Okay, you have a 5010 and a 5020. Yes, you can use port speed of 1 gig. So the 5010, it's the first 8 ports where you can set the speed to 1 gig. And of the 5020, it's the first 16 ports that you can use. And the command is speed 1000. So keep in mind the first interfaces are the one you can use to set the speed.
Okay, let's go to our next question. Assume the following: a Nexus 5K with a 2K fabric extender. The fabric extender fails and a new one is requested from the TAC. Assume when the 2K goes down, all the configuration is lost or gone from the 5K. When the new 2K is connected, do we have to reapply the configuration for the relevant portion of the 2K?
So we have a 5K and a 2K, and your fabric extender fails. You get a new one. So when you get a new one and just connect it directly, it will come up with a FX number configured. However, I encourage you to save your configuration because you may need to reapply it. There will be yeah, that's save your configuration, and And the FEX number will be defined, but you will have to enter your other settings for the ports.
All right. Next question. Does the Nexus 5K provide 10 gig speed to every single port?
Yes, it does. You can use every of its ports with a 10 gig speed. Correct.
All right. Let's get another question here. Please do submit any more questions if anybody has them. Is Jumbo MTU enabled by default on the Nexus 5K?
Jumbo MTU is not enabled by default, so make sure to configure this as we saw in our Jumbo frame section slide and enable the Jumbo frames for the 5K. By default, it's disabled.
Very good. Another question here. What kind of L3 features will be supported in 5K, in Nexus 5K? EIGRP, OSPF, RIP2, ISIS, MPLS, VRF Lite, etc.
Very good question. So as of today, the 5K is a pure layer 2 switch, and there will be actually an additional module that will provide layer 3 features, a daughter card that you'll be able to place in your extension slot. So the features that will support it, I'd like not to go exactly in detail for now, but yes, you will have routing protocols and you'll have a good handful of layer 3 features. If you'd like exactly to get all the details, I could provide you this during our Ask the Expert event following today.
That's another question here. Can I use a ethanalyzer to sniff traffic between two hosts?
You should use PAN and not ethanalyzer. Keep in mind that ethanalyzer is for traffic that is going directly to the 5K. So in this scenario, use a PAN.
Another question here. What SFPs can I use with Nexus switches?
Good question. So there's a matrix compatibility guide. For the 10 gig, we support the SFP 10 gigs, which are the SR, the LR. We support the Twin X cables with the 1, 3, 5 meters, all the Twin X cables available. We also support the FET, which are the SFPs, and FET stands for Fabric Extender. So those are the SFPs to connect to FEXs. Those are for the 10 gig. For the 1 gig, you can use the JLCTs, for example. Make sure to use Cisco SFPs, else you'll get unsupported SFP message.
All right, next question here. Is RSPAN supported on the 5K?
RSPAN as of now is not supported. There is ERSPAN support, but not RSPAN at this point. It's in the works. It's in the works, but as of today, RSPAN is not supported.
All right, next question here. What would you use as a core to go with the Nexus 5K?
Good question. I would use either 7Ks as a pair, or I would use Cat 6Ks with VSS. But this depends also on your business needs. There's other ways. There's other switches you could use. You could use Catalyst 4500s. You could use other upper switches depending on exactly what is your deployment. What are you trying to achieve? If you'd like 10 gig up, well, yes, certainly use if you can 7K as a pair. If not, a VSS, a Cat 6K pair in VSS. Those are those that would come to my mind first, I would say, in large data center deployments. But you could use other switches as well, depending on what exact design you're trying to achieve.
Okay, let's go to our next question here. Would we be able to upgrade existing Nexus 5Ks to support L3 features and cards?
That's a good question. There may be a need to change your Nexus, but not for the L3. So, there will be a newer hardware coming, but for L3 you will be able to use it with your actual. So. Long story, but no, you don't have to upgrade your hardware to support the L3 feature card.
All right. Got time for one more, I think. Is the Jumbo MTU affecting performance if it's configured unnecessarily?
No, it doesn't. It doesn't. You can configure it, and this all the traffic is hardware switched. So actually, if it's not configured, the 5K will actually try to reduce the size of packets that are larger. But if you configure it, it will not be affecting performance. So there's no reason why not to configure it.